Here we have the alternating series of n negative 1 to the n times tangent of 1 over n. And we want to show that this alternating series diverges. And so let a sub n be the n times tangent of n, tangent of 1 divided by n. And so the limit is n approach infinity of b sub n this would be the limit of n times tangent inverse of 1 over n. And then we can rewrite this like this. Dividing by 1 over n is the same as multiplying by n. As n approaches infinity, 1 over n will approach 0, and tangent of 0 which is 0. And so at the bottom we also get 0. So we get 0, the indeterminate form of 0 over 0. And therefore we can use L'Hopital's rule. And so here we just take the derivative of the top and the derivative of the bottom. And so first let's write this as with the continuous form. Since n is discrete, n just takes on values of 1, 2, 3, 4. But to use L'Hopital's rule, we need a continuous variable. And recorded the derivative of 1 over x is as follows. And so we want the derivative of 1 over x. So this is 1 over x is the same as x to the negative 1. And so the derivative here being negative 1 times. And then we subtract 1 from the exponent. And so the x to the negative 2. And then this becomes negative 1 over x squared. X to the negative 2 is the same as 1 over x squared. So the derivative of 1 over x is negative 1 over x squared. And then recorded the derivative of the tangent is secant squared. So we have secant squared of 1 over x. And then the chain rule is we have to multiply by the derivative of 1 over x. So we recorded the derivative of tangent of x is secant squared of x. But here we have tangent of 1 over x, and therefore we have to use the chain rule, and so it would be secant squared of 1 over x times the derivative of 1 over x. But the derivative of 1 over x, again, this is negative 1 over x squared. The negative 1 over x squared will drop out. This negative 1 over x squared and this negative 1 over x squared. So what's left is just the secant squared 1 over x. And as n approaches, as x approaches infinity, 1 over x will approach 0, so we get secant squared of 0, which is 1. And so the limit of base of n is equal to 1, which is not 0. And therefore, the series right here, this series diverges by nth term test. And again, the nth term test, it says that if the limit of base of n, if it does not go to 0, then the series diverges. And so we have shown that the limit of base of n is not equal to 0, and therefore this series here diverges by the nth term test.